Okay, today we're going to talk about expanding on the video that we had last time. We learned about vertical asymptotes and holes. Now today we're going to do horizontal asymptotes, X-intercepts, and Y-intercepts. Okay. The idea of a vertical asymptote was very straightforward. You don't want to be divided by zero, you can never cross that. Horizontal asymptote's a little bit different. This kind of goes into arguments when you get into calculus about limits and things like that. So unfortunately, for now, we just kind of look at these three situations that could happen. We kind of look at the degree of the different polynomials that are in our rational expression or equation. If the degree in the numerator is less than denominator, then our horizontal asymptote is always y equals 0. If the degrees are the same, we divide the lead coefficients, and that'll be a horizontal asymptote. And if the degree in the numerator is greater than the degree in the denominator, then we don't have any. Okay? So that's how horizontal asymptotes work. Okay, so let's look at an example here. Let's say I have 1 over 2x plus 2. And let's say we want to label the horizontal asymptotes of this. Well, first thing we should always do is always factor. Because you never know what could happen with holes and things like that. So this equals 1 over 2x plus 1. Okay, just to be consistent with all the other things we've done. Okay, nothing cancels out here. Okay, that's good. So now we got to look at the degrees. Well, nice thing about factoring too, after you've factored everything, you can always count the number of x's you got. We have no x's on the numerator, so our degree there is 0. But here, we only have this 1x raised to the first power, so our degree is 1. So the degree is 0. The degree equals 1. So in this case, the numerator is less than the denominator. This is case 1, so our horizontal asymptote will be y equals 0. Okay, now, even though it's not written on the side here, we're going to look at X-intercepts and Y-intercepts as well. So for X-intercepts, remember, if this were equal to 0, because equal to y or something like that, y equals 0. So let's just say you had, y equals this here in the beginning. Well, for the X-intercept, we know that y equals 0. So we're going to replace that with 0. So I'm trying to find a way to turn this fraction into equaling 0. And if you think about it for a second, we know with fractions that 0 divided by anything gives us 0. So if I can find the x values that I put into the numerator to get that equal to 0, those will be my x-intercepts because those will make the whole fraction equal to 0. Okay. So for my x-intercepts, we're able to take our numerator and set it equal to 0. So this is going to tell us our x values that make it 0. Well, this is nonsense. 1 does not equal 0. So for our x-intercepts, we have none. Okay? There are no x-intercepts to this. It doesn't cross the x-axis. For our y-intercepts, okay, well, we remember for y-intercepts, x just equals 0. So we're just going to set x equal to 0. Now I'm going to have 1 over 2 times 0 plus 2. That equals 1 over 2. 0 plus 2 is 2. So my y-intercept, x was 0, y was 1/2. Okay. So I had a horizontal asymptote at y equals 0, no x-intercepts, a y-intercept of that. Okay. Try to do the next one on your own, and then we'll come back together. Remember, try to find the horizontal asymptote, the x-intercepts, and the y-intercepts. Okay? Okay, try your best. Welcome back. Okay, first thing we got to do with all of these rational expressions and equations is factor. So, I'm going to factor the numerator first. Bring in an x. x squared minus 16. This here is a difference of squares. So this equals, and this is all over something, x times x plus 4, x minus 4. Okay, here they each share 2 in common, so I can factor out 2. Okay. Then this here I could use my ACB method. Remember, if you don't know how to do that, look back at previous videos. And that's going to equal 2 times Okay, there we go. Okay, now looking at this, we don't see anything that really cancels, so that's, this just avoids any holes or anything like that. Okay, so now we can actually look at the degree to see what kind of horizontal asymptote we have. Okay, so looking up here, I'm multiplying everything. I have 1, 2, 3 x's, and you can think to yourself, if you went backwards, you had x to the third. So my degree up here is 3. If I look at this one, 1, 2, I have 2 x's. So my degree here is 2, and that's back to here. Highest exponent was 2. The degree in the numerator is greater than the degree in the denominator. This gives us case 3. So our horizontal asymptote, there are none. This is actually called the slant asymptote that you'll learn later on, or an oblique. Okay, now we got to find our x-intercepts. Remember, for our x-intercepts, we're trying to get this whole fraction to equal 0. So we need to find the x values that make the numerator equal to 0. So we need x times x plus 4 times x minus 4, have that equal to 0, because this tells us the x values that get that equal to 0. Now you can use the zero product property, set each of these equal to 0. So x equals 0, x plus 4 equals 0, x minus 4 equals 0. This one's good. X equals negative 4, x equals positive 4. So our x-intercepts are 0, 0, negative 4, 0, 4, 0. So we have 3 x-intercepts here. Okay. And then for our y-intercept, remember we're going to set x equal to 0, but you could be very smart right now. You could set x equal to 0 here and figure out what it is. Or you can even look at here. If you know you have your x-intercept at the origin, and this is a function, okay, set equal to f of x, it's only going to cross the y-axis once, so I know right away that my y-intercept is going to be 0, 0. And if that didn't make sense to you, just plug in 0 for x. 0 times anything is 0, so the numerator is 0. 0 divided by whatever this is, still 0. Okay? Okay, try one more. Again, try doing this one by yourself before you watch the video. Find the horizontal asymptotes and the x and y intercepts. Okay, welcome back. So first thing we want to do is factor. Well, lucky for you, it's already factored. Great. So now we can look at our horizontal asymptote. Okay? So our degree in the numerator, well, we have x to the first power, so our degree here is 1. Degree in the denominator, x to the first power, degree is 1. Now this is the second case where the degrees are the same, so our horizontal asymptote is when we divide the lead coefficients. So the coefficient here, so y equals, the lead coefficient here is 3, divided by the lead coefficient here, there is a 1, so 3 over 1, or, so our horizontal asymptote is y equals 3. Okay? Now for our x-intercepts, Okay, remember we're trying to make this whole fraction equal to 0, so we have to take the numerator and set that equal to 0. This comes out to be what, 4/3? So our x-intercept is 4/3 comma 0. So when x is 4/3 here, that whole thing becomes 0. And then finally for your y-intercept, we want to set x equal to 0. So you get 3 times 0 minus 4 all over 0 plus 4. This is negative 4 over 4, which equals negative 1. So our y-intercept is 0, comma negative 1. Okay, so now you're able to find horizontal asymptotes, x-intercepts, y-intercepts, vertical asymptotes from the other video, and holes. Now we're going to bring all this together to make the graphs of these things. Okay?